Hey guys, this is still Phyllis here, and I'd like to welcome you guys to this lab. And today we have somehow pretty much easy lab, and we're just going to do a quick configuration with this module. So basically, the lab is already partly pre-configured. So and we'll just be configuring what is being asked of us for this lab. So the learning objective here configure VLANs, configure rapid spanning tree, um, Pvst plus and load balancing, and to also configure to do a little tweaking at the different port interfaces and setting BPDUguard as well. So just to further enhance the interface connectivity with the other switches on the network. So basically, these are all the things we are expected to be familiar with and perform at the close of this lab, which will give us 100%. As you can see right now from the bottom right of my screen is at 0%, but by the end of this lab we should be at 100%. So um, just to jump into it, let's execute the first requirement that is being requested of us on this lab. So the first part we're going to do is going to be step 1. This portion right here, as you can see it says refer to the topology and which switch ports on S2 are activated for end users devices, and you want to enable these switch ports and put them in the access mode. So basically that's exactly what we are going to be doing. So it's S2, so let's go to S2. This is S2 right here. Going to pop this one open, and let's just move it to the left. Open that. And I also took the liberty to increasing our font size within the router. So our first requirement here is to enable the various ports that connects end devices. So I'm just going to move this to give you a better picture of what we are talking about. So as you can see on switch 2, we have these are the end devices right here, PC 1, 2, and 3. So we have FO11, FO18, and FO6. So those are the ports we are going to put in an access state and also going to enable them. So but now we should know how to configure interfaces, but if we are still struggling, just follow along, and this should be a very easy ride. So we want to do config, and we want to do the range command. You could do them individually, or you could do them per range. It make it faster if you do the range. So that's what we are going to do. So you want to do interface range FA0. So let's start with PC1, which is on port 11. You do a command, and PC2, which is on port which on PC on port 18, and finally FO06, which is on port 3, on port 6, PC3. Oh, come on. Okay guys, here we go. So access port, that's what is been asked for. Switch port mode access, and you put in your no show state to turn it on. So these ports are already on by the mere virtue of that command execution. Okay, so basically this first part here is certify. Okay, now let's move on to step number 2, creating the VLANs, and we are supposed to create VLANs on all the 3 switches. So that's what we are going to do. So I'm going to close 2. I'm going to start from 1 because I don't want to get confused. Okay, that's how it is. This is configuration. You have to be organized. So let's do enable conf t. Now you can also go ahead and name the VLANs as you please, but per the lab we are not required, so just going to go strictly into it. So to do the VLAN, and create a VLAN database, basically you can just do this 20, 30, 40, 50, 60, oops, 70, 80, and not 90, 99. Gotcha. Okay, and you want to repeat these steps on all these switches. Now if you had a DTP server, that would just be an easy fix for you, because you have just do the configuration on a single switch, and it will be populated across the network to all the switches that you meant it to be populated on. But since this is just an easy network, so we're gonna do it manually. So VLAN 10, come on, 20, 30, 40, 50, 60, 70, 80, and 99. That's that. And now switch 3. So basically we're going to do the same for switch 3, and we should certify that requirement. Okay, enter VLAN 10, 20, 30, 40, 50, 60, 70, 80, 99. Okay, so basically this requirement right here is done. Okay, create VLAN on all the switches. Now let's move over to step number 3, assign VLANs to switch ports. Okay, so this is what we're going to do. Port assignments are listed in the table from the beginning of the activity. So we're going to go back up here, and this is what the professor is talking about. So that's exactly what we're going to be doing, and these are all assignments on switch 2. So we're going to pop this open, and going to assign the switch ports for VLAN. Okay, and so, and these are all access ports, remember. Okay, so going to do int f0/6 switch port access VLAN 30. Okay, and if you're not sure, why not do a no shot? int, it wouldn't hurt. Okay, f0/18, enter, switch port access VLAN 20. int f80/11 switch port access VLAN 10. Remember, initially we already set those switch ports more to an access port, so you don't necessarily need a command anymore. No short. Okay, so basically that is that. Let's close this. Now we're gonna move on to the next stage of the configuration. So assign switch ports, that is done. verify the VLANs are in the VLAN database. We could definitely do that. To give you a shot, you do a quick do show VLAN brief. Okay, so these are all of our VLANs: 10, 20, 30, 40, 50, 60, 70, 80, 90, 99. So if you do So basically, if you do all those commands, the same command on the other switches, you should be able to see your VLAN database. And if you did it right, you should find your VLANs in those databases on each switch. So now let's do step number 5. Use the appropriate command to configure ports 1 through 4 on each switch as a trunk ports. So this one again, we can use the interface range command, since they are group of ports. Okay, so let's start with switch number 1, and we're just going to use the interface range command since that is faster. Exit out of this. We're going to do interface range F80 1 2 4. You enter, switch port more trunk, and then you enter. Okay, switch port trunk. These are all the commands you're gonna need to do this, to execute this portion of the lab. Switch port trunk native VLAN 99. So as you can read from step number 5, it says use the appropriate command to configure ports 1 to 4 on each switch as trunk ports and assign these trunk ports to a native VLAN 99. So basically, that's exactly what we are doing here. So do enter, and we'll just do a no shot to confirm that these ports are on. Now you're gonna get ports mismatch and inconsistency because you've not changed the native VLAN on one switch, which is connected to another whose native VLAN is VLAN 1. For this switch, we are using this native VLAN as VLAN 99. That's why you are getting these prompts. So you should be fine once you execute the commands on all 3 switches. So we're going to go to the next switch here. Is going to be S2, and do enter, exit out of this one. Interface range F80 1 2 4, switch port mode true, and switch port trunk native VLAN 99, and we'll do a no shot and close this one. And on switch number 3, you want to do basically the same, because that's what the lab requires us to do. Exit out of this one. INT range FA0 1 2 4, switch port mode trunk, and switch port trunk native VLAN 99. Now consistency should be restored, as you can see from the prompt right here. But let's do a no shot just to confirm, even though I'm pretty sure that interface is on. So that is that. Next, it says verify that the switches are correctly configured by pinking between them. Just to certify that requirement, let's do a ping, and so it won't take it. Now they are failing because the configuration isn't complete, but once we get done, this computer should be able to ping between each others. Right now that isn't a management VLAN configure as well, so that will be the next step we are going to do on these switches. So it says next, assign the VLAN trunk to native VLAN brief, and configure the management interface on all 3 switches with an address. So we're going to go back up here, and this is what we're going to need for all these switches right here. That's what we're going to need. Okay, so let's do that. Start on S1 and exit out of this one. Interface VLAN 99. Now you have to assign an IP address for management purposes. You have to assign an IP address to the management interface, and that's exactly what we are going to do on all three switches. Okay, and IP add 172.17.99.11. It's a /24, so it's 255.255.255.0. You do enter. You could do a no shop, but it wouldn't change anything. So that's S1. Now let's move over to S2. Do an exit. Interface VLAN 99. Turn the interface on. IP add. It's going to be 172.17.99.12. 255.255.255.0. Do enter. You could do a no shot or you don't. Okay, and let's move over to S3, and we'll do the same for S3, and we should certify that requirement as well. Exit out of this one. Interface VLAN 99. Enter, and IP add 172 17.99.13. 255.255.255.0. Enter, and oh shot. So this requirement is certified. Configure the management interfaces on all three switches with an address. That is done. The next step is to configure rapid spanning tree protocol, and that's what we're going to do. So we're going to enable rapid spanning tree protocol on all three switches. Okay, so spanning tree mode, rapid, do a tap, it give you that. That's enabled. That's all you need. And pop numbers 2 open. Do the same. Exit out of this one. Spanning tree mode rapid Pvst, and that's it. And switch number 3. Exit out of this interface. Spanning tree mode rapid Pvst. Okay, so that is done. Next, it says configure S1 to be the primary route for VLANs 110, 30, 50, and 70. So this is S1 right here. Going to pop that open, and we are going to configure our primary route. This is to disable looping in the network. So that's the function and that's the role of our spanning tree, and to also enable fast convergence, but we will get to that point later before the end of this lab. So let's do this part. Configure S1 to be primary route. So you want to do spanning tree VLAN 1, 10, 30, 50, and 70. Root primary. That's what the instructor intended. Okay, enter, and that's it. One, 10, 30, 50, 70. Great. S3, do the same for S3, but with different VLANs, not the same VLAN. Spanning tree VLAN 20, 40, 60, 80, 99. Root. So he says it's going to be our primary root. Okay, so it says configure S3 to be a primary root on S with this with the VLANs 20, 40, 60, 80, and 99. Okay, so it's going to be primary as well. And you enter, and that should certify that instruction. Now S2 will be the secondary. Okay, now this is strategic planning of your network. You don't want loop in your network, you have to implement spanning tree protocol, man. Spanning tree VLAN, all of the VLANs are on switch 2. So just going to do 1, 10, 20, 30, 40, 50, 60, 70, 80, 99. Okay, and this is going to be root secondary. Okay, because that's what the prof is asking right here. S2 to be the secondary root for all of the VLANs. There you go. So you do enter, and that should certify that command. Okay, next it said verify your spanning tree by using a show spanning tree command. Okay, let's do that. Do show spanning tree. Oh boy, do show spanning tree. So basically this is our spanning tree, and as a result of our command we force some of the ports, the interfaces, into a forwarding state and others into a blocking state. So basically they are on standby, if you will. So there's only one who is going to be forwarding packets, and if this main forwarding interface is to go down, then the other interfaces will take over from the forwarding switch. But for now they are in a blocking state until they are needed during a different time in during the network. Okay, so there you have it. So it is properly configured. Next we are supposed to configure port fast, this command right here, and after the configuration of this one we should be fine. Okay, so on S2, according to our lab, port fast causes port to enter the forwarding state almost immediately by dramatically decreasing the time of the listening and the learning state. Port fast minimizes the time it takes for the server or workstation to come online. So it's going to be configured port fast on S2 interfaces that are connected to PC. So port fast is frequently and usually configured with end devices, okay, and always in an access state, not a trunk state. Is not advisable to configure port fast with interfaces that are in a trunking mode. So we want to do that with interfaces that are in an access mode. So that's what we're going to do right here. So we're going to do interface range. Okay. F is 0 slash 11, comma F is 0 slash 6, and F is 0 slash 18. If I'm right, that's our connector interfaces 6, 18, 11. 6, 18, 11. To enter spanning tree port fast. Okay, there's that. The next step, as we are required, is to enable spanning tree BPDU on the interfaces. So it says guide enhancement allows network design to enforce STB domain borders and keep the active topology predictable. Configure BPDUguard on S2 interfaces that are connected to PCs. So let's do that since we are already into that interface and they want to do a spanning tree BPU enable. Bam. Okay, so basically that's all we need to do. Exit, and you can do copy, run to save your configuration. So as you have it right here, we are at 100%. So that certified that the configuration went just well. So remember now, to do the port fast, you have to do it on the interface, not on the router. You want to do it on the interface. Okay, so let's hope this went great, and all of our interfaces are up, and so some are in blocking state while others are fully functional, and there you have it. A very easy lab, less than what, 25 minutes, and this should be far more easy. If you got any questions, please kindly shoot me an email. I must return my emails, and you can also kind of go ahead and like my channel, like my video, and more videos will be coming with more CCNA materials. Okay, I'd like to thank you for watching. I'd like to wish you a happy study. Okay, you take care then. My name is Theophilus, and please kindly subscribe as well. Thank you.